Hi viewers, welcome to this video on mathematics. Today we are going to look at a question from a topic of integration, application of differentiation and integration. And the question reads, a stone is projected vertically upwards and its height s meters after t seconds is given by s equals to 16t minus 4t squared. Find the maximum height attained by the stone. Part B, velocity when t is equals to 1 and acceleration when t is equals to 1. So let's get started. We have to actually look at displacement as the function. So we know that for us to move from s to v, we need to differentiate. And to move from v to a, we also need to differentiate. The only time we integrate is when we are moving from down to up. Okay, so when you're moving from a to v, you integrate. V to s, you also integrate. Okay, so we need to remember this concept before we do this problem. So we are given s as 16t minus 4t squared, and we know that v is ds over dt. Okay, so change in s over change in t, we differentiate s with respect to t, and this gives us 16 minus 8t. Okay, so we need to remember that maximum velocity occurs when velocity is equals to 0. So at maximum height, velocity is 0. So we come here and set velocity equal to 0 and determine the value of t. So 16 minus 8t is equals to 0. So 8t is equals to 16 and t is equals to 2 seconds. So maximum height will occur when time is 2 seconds. So we take 2 seconds and substitute into s. So we have s is 16 into 2 minus 4 into 2 squared, and this gives us s equals to 32 minus 16, which is 16 meters above the ground. Okay, that's it. Going to the second one, it's now easy because we already know velocity function is given by 16 minus 8t, and we want to substitute t equals to 1. So v will be equal to 16 minus 8 into 1. So we have 16 minus 8. So this gives us that v is equals to 8 meters per second. Okay, that's done. Acceleration, going back to our way of doing things, when you're given velocity, to move from velocity to acceleration, we differentiate further. Okay, so we already know that v is equals to 16 minus 8t. So a is equals to dv dt, change in v over change in t, and this is derivative of this is 0, derivative of this is negative 8. So a is equals to minus 8. And since this acceleration is a function which is independent of t, so it doesn't matter what t is, because acceleration is always equal to minus 8 from the function given. So after we differentiate 16 minus 8t, we've gotten minus 8, meaning that this acceleration function is a function that is independent of time. So irrespective of whether time is 1 or what, acceleration is minus 8 meters per second. So we have a is equals to minus 8 meters per second square. And that's how it is. Thank you.